Hello everyone, welcome back to our Python programming masterclass. This will be our part 2 out of part 7. Today we'll be talking about control flow in Python. Under control flow, we have the conditional statements, that is the if else. We also talk about for loops, while loops, break and continue, and pass. As you all know, my name is Oloyede John, the campus lead of Campus Bowen University, which is governed by Data Science Nigeria. And if I might also add, in today's class, we'll be having a little challenge in which the first two people to submit that challenge will be getting data grants, meaning you'll be getting free data. So let's start. So as I said before, we'll be talking about Python control flow, which under we have the if else, for loop, while loop, break and continue, and also pass. But before I jump into the control flow, I would like to talk about output, input, and import. And these are various widely used functions for standard input and output operations in Python. We will start with output. You can use print function to output data to the standard output device. And up until now for input, we have been basically working on a static program. That means we are the one inputting the variables ourselves. But there'll be some times where you need the user, which is not you, to input the values of various variables. At this point, we use the input function. There's also the import, which we use to carry out import functions. Let me show you quick examples of output, input, and import. Simple output where we use print, you basically do print. Prints out John likes food. You can also do A is equals to 5 or A is equals to 10. Print the number written in the value, the variable A is. And when we run this, you see it gives us the number written in the variable A is 10. Now let's talk about input using the input function. We we have a simple code like this. We want the user to enter a value into a variable. We can say give the variable number. Then now to prompt the user to input that value, you use the function input bracket enter, that is enter a number. It's as simple as that. But to print out, now to make sure when you run it, this is what shows. Enter a number. You input 10. Now to let's see if number 10 as the value number 10 has been imputed into this variable. We simply do print number. As you can see, the value 10 has been imputed into the variable. Let me give more examples. You can also do int. Let me not use int. Let me use int. Remember your input function. Input, please enter your age. Your input 50. Now to print it out, sorry, a second. Now to print it out, you basically just say print is age is age. The print out its age is 50. We can also jump into the import function in which we use. But first of all, let me say this: the import function is a little bit different because when our program grows bigger, it is a good idea to break it into different modules. And I will explain to you saying that a module is a file containing Python definitions and statements. Python modules have file name and end with the extension .py. Definitions inside a module can be imported to another module or the interactive interpreter in Python. We use the import keyword to do this. For example, we have the math module whereby if we need to print out, if we need to write pi, we don't always need to be writing pi is equals to creating a variable and saying pi is equals to 3 points. Wow, forgotten the I've forgotten the number for pi. 3.14. We don't always need to say 3.14. Pi is equals to 3.14. We can basically do import math print math dot pi. And now when I run this code, you see that the value of pi has been written down for us. So now anytime I need to run a simple code, like I need to do, let's say I need to calculate the variable, the area of a circle. We first start, let's give the radius. Radius is equals to 23. We then write the simple formula for area, which is area is equals to, as you remember, we said we are not going to be putting pi into a variable. We basically say math dot pi, which is pi r squared, multiplied by r times r. When we run this, we now print out area. When we run this, r is not defined. Oh, sorry. Forgive me for that. Instead of me putting radius, I put r. Forgive me. Area is equals to math pi multiplied by radius times radius. This is one of the reasons why we always need to simplify our variable names. Area. Now when I run this, you see the result is brought out there. We can now move on to our main focus of today, which is control flow. We'll be starting with conditional statements. And what do we know about conditional statements? Normally, decision making is required when we want to execute a code, only if a certain condition is satisfied. That's where the if, elif, else statement is used in Python for decision making. Basically, look at this flow chart. We have a simple condition that is needed to be done. Then we say, if condition is true, print out this. If condition is false, print out this. Let me give you a simple example. We are trying to calculate whether a student got A, B, C, D, or E. Now you write a simple if statement saying if the student, or let me put myself as student, John, his score was 75. You now write a simple if statement writing if John's score was 30, in between 0 and 45, he got F. In between 45 and 55, he got D. In between 55 and 65, he got C. In between 65 and 75, he got B. In between 70 and above, he got A. That is what we use if statement, if, elif, and else statement for. The if statement, as you see that condition false, true. Meaning if the condition is false, print out so and so. True, block of code. Meaning that block of code is what you want the program to do. Without, let me not talk too much. Let's jump into the IDE and write some code. So I'll write a simple if statement. So let's start with a simple variable. Num is equals to 10. Here's where our if statement comes in. If num is greater than 10, you put your semicolon. Now, for those who have been programming before, we know our normal programming in other programming languages like JavaScript, Java. If you are going to write an if statement, you normally put a bracket and input num is greater than 1, greater than 0. Then outside that, you put a curly brace, then input your code. But this is not how Python does if statements. Python is a simple programming language. So all you just do is write num is greater than 0, and you put your semicolon instead of a curly bracket. Then you write your block of code. Print num is a positive number. If I run this now, it's going to print out 10 is a positive number. But I just want to write something that will always be showing even if the if statement does not work. So you write print John is happy. This is outside the if statement. So no matter what the condition is here, this will always be printed. Now if I run this, as you can see, 10 is a positive number and John is happy. Now what if the value inside num was less than 0? So I'll just copy this instead of typing over and over again, and I'll put this here. Let me put this as -6. Now when I run it, as you can see, only printed John is happy. It didn't print -6 is a positive number, because when the IDE ran, it saw num as a negative number, which is less than 0. It met this decision-making statement here, saying if number or num is greater than 0, print num this is. If not, leave that condition and move to the next line and print John is happy. We now move on to the if else statement, which this flowchart explains it this way. Condition, if the condition is true, block of code as we did here before. If the number was greater than 0, print out so and so. Now, unlike the previous code whereby it didn't print out anything if it was less than 0, on an if else statement you can print out something else if it is less than 0. Right here you have condition false. If condition is false, do something else and continue to the next line. Let's jump to our IDE and write a simple if-else expression. Num is equals to 50. Oh, sorry, writing in the wrong spot. Num is equals to 50 if num is greater than 0 or equals to greater than or equals to 0. Print num uh, is a positive number. Let me change this variable to something less than 0. Input minus 76. Now, this is the first condition, but 76 is less than 0. What happens next? That's where you move on to your else statement. Then you also do else. Remember, for every conditional statement, you remember your semicolon. Else, print num is a negative number. Now, if I run this, you can see it brings out minus 76 is a negative number. Now, let's move on to the elif ladder, which when we need to write change conditional statements, meaning what if, like the example I gave before about student scores, whereby if a student got A, B, C, or D, if the student score is 50, how do you know if you got A, B, C, or D? That's what we call a change conditional statement, or a change conditionals, meaning you have a condition for if you get ratio between 0 to 40 for F, 40 to 50 for D, 50 to 60 for C, 60 to, and so on till you get to A. So let's move on to our IDE to write the conditional statement for scores or grades. I've already pre-written it, so I don't have to be typing over and over again. This is basically what you need to know. You have grade, which is the person's score, equals to 60. Now, if the person's grade is greater than or equals to 0, and remember the AND operator we talked about in the last class, grade is less than or equals to 39, print Janet got an F. Elif, that's where you use the elif statement. Elif grade is greater than or equals to 40, and grade is less than or equals to 49, print D. That's Janet got a D. Elif, grade, and so on till you get to A. Now, for A, you don't need to stop. You already know that from 80 to 100 is A. So you just write Elif grade is greater than, if L, that's else if, I call it else if because it's just joined together to make it more simple in Python. In other programming languages, you mostly have else if, but in Python is elif. So elif or else if grade is greater than or equals to 80, print Janet got an A. Now else, you always end your if elif else statement with an else statement, meaning after all this is done, what happens if none of these conditions are met? Meaning, what if I put A there, a string, or a symbol? What if I put it here? What is it meant to print? It prints out invalid score. Now let's run this. As you can see, Janet got a C because 50 from ratio 50 to 69. Now, what if I put in an invalid score or a negative number? So let me copy this, put it here, and put grade is equals to minus 40 or 30. Let's see what comes out. As you can see, it prints out invalid score because none of these conditions are met. We also have something called the nested if statement. That is when you have an if statement inside another another if statement. Let me show you the flow chart for that. This is the flow chart. You have condition false, condition 2 block of code true, condition 3, or should I say condition 2, condition 3 false, false, false. For this, in this flow chart, you might not really understand it, but let me show you in our IDE. We have, let's say, a simple, let's use that input function that we're using at the beginning to input. This time we want the user to input a variable. So we say num is equals to float, because we want an integer, not most times when you use when you use input, it collects it as a string, but we want an integer. So we say float input, remember your input function, enter a number. Now down to our conditional or our nested if statement. So if num is greater than 0, greater than or equals to 0, we have another if statement inside this if statement. If again num is equals to 0, remember your semicolon. Now you do whatever you want. You do your block of code as it says in the flowchart. Print 0. Else print this is a positive number. Now we close the first if statement again with an else statement, which is else print negative. This is a negative number. Now let's run this. Invalid syntax, enter a number. Oh, sorry, I forgot to put my semicolon. I forgot to put my parenthesis. This is a string. I keep forgetting that. I don't know why. Let's run this. Now I input my number. If I input 5, it prints out this is a positive number. You see what it did? It first went into this if statement. If num is greater than equals to 0, it checked it. Num is greater than equals to 0. So it didn't do anything. It didn't jump to the ending because num is greater. You see what happens if I put minus something. So here we have num is greater than equals to 0 because it's 5. It moves in. Here we have num is equals to greater than or equals to 0 because it's 5. Then it moves in to this if statement here saying if num now is equals to 0, print 0, else print this is a positive number. So this is what it printed out. Then it skipped this because this is not part of, this has already been cancelled out because it is greater than 0. Now let's test it out again and write, let me put 0. Let me put 0 and see what happens. As you can see, it prints out 0. It enters here again. You first read this. It sees that it's greater than or equals to 0. Then it moves to this. It is equals to 0. Print this and the condition ends. It breaks from here. Now let's try a negative number. Minus 5. As you can see, nothing in this if statement ran. It went from this, if number is greater than or equals to 0, print else, print this is a negative number. So it went, we found out that the value inside num was not greater than 0. So it didn't run this, it went straight and printed out this is a negative number. We will now be moving into loops. This is what we use when we have much values to run through in an if statement. Like, imagine we need to make a decision of this. Remember this code here, this is for just one person. What if we need to check for a list of grades, a list of students grades, 30, 50, 60? What do we use? That is where the loop comes in. A loop or loops in Python are used to iterate over a sequence, either list, tuple, or strings. Remember in our last tutorial we said lists, tuple, or strings are like a box where you store various elements. So a loop iterates over it over and over again. We have two types of loops. We have the for loop and the while loop. Let's write a simple for loop in our IDE to add the sum of different numbers. Sorry, give me a second. I think this is still running. Let's keep here. We have a simple list of numbers. We put in our numbers. Remember, for a list, we use braces, whereby you have 6. Let's put in our number 6, 5, 4, 3, 2, 1, 79. Now, normally, before, if I wanted to add these numbers, we'll have to be doing 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 69 plus 74. But we can write a simple loop that will a simple for loop that will iterate inside here, add 6 plus 5, 4, 3, 2, 1, 69, and 74 without writing much code. This is how you do it. Let me write a simple comment. You first create a variable to store the sum of all those numbers. Simple comment, variable to store the sum. Then we create a simple variable. Sum is equals to, we give it 0. Now for the for loop to iterate over the list, for much understanding, let me put another comment again. To iterate over list, we basically write for val, which stands for the numbers which stands for variable in numbers, which is the variable here, or the list written here. Seems I made an error. Yes. In Python, don't forget your semicolon when writing control flow statements. Semicolon, sum is equals to, can you remember before when we needed to do plus equals to or plus minus? When you're adding the same thing over and over again, sum plus val. I can simply write this, sum is equals to sum plus val, or I can do sum is equals to plus equals to val. Then I print out the sum is sum. Now let's run this. Now as you can see, it brings out sum is equals to 164. So it added 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 69 plus 74. Even saying it is quite stressful. This is quite shorter. Instead of writing, I don't even want to write it. It's too stressful. Under for loops, we also have the range function, whereby we can generate a sequence of numbers using range. Meaning, if you want to find from 1 to 10, you can simply just write range 10, and to generate numbers from 0 to 9, because those are the numbers inside 10. But there's one thing you need to know. The range object is very lazy in a sense whereby it doesn't generate every number that it contains. When you create it, it just generates the first and the last. So you can iterate it using in, learn, or get item. Or you can use, or to force the function to output all the items, you can use the function list. Let's run a simple code. Print range 10. When I run this, it just prints out 0 and 10, the first and the last. But to force it to print out the list of every number inside this 10, what you'd write is print range list. First click list, then range 10. And when you run this, it prints out 0 to 9. So we move into while loops. The while loop in Python is used to iterate over a block of code as long as the test expression is true. So as long as this is true, the code keeps running. If it's false, the loop breaks. So we generally use this loop when we don't know the number of times to iterate beforehand. Let's say I need to find the sum of numbers in 10. I don't know how many times it's going to go. I'm going to iterate in 10. So all I need to do is write a simple while loop. Let's test this in our IDE with, we first prompt the user to input a value, which is n is equals to, remember, when you are prompting the user, it always accepts as a string, so you have to change it to either float or int. Input, enter the value n. After that is done, initialize your sum and counter. The counter is what will help you check over and over again if the condition is met. So we say, let's write the comments for so you can use to remember. Initialize sum. Sorry. Initialize sum and counter. Sum is the variable that stores the added numbers. 0. I is equals to 1. Then we write our while loop. While I is less than or equals to n, go into that loop, add the sum, which is sum plus equals to I. Meaning while I is less than n, go into that loop, add, and since I here is 1, add 1 plus 1, then store it inside sum. Then you update the counter again. That is how you know if I has passed 10. So you update the counter and do I is equals to I plus 1. Let me write a simple comment. Update counter. So what you're basically doing is I first goes into the loop, checks is less than 10, it adds 1 plus 1, it stores the variable into sum. It goes again, is 2. It goes into the loop, it goes there, checks 2 is less than 0. It adds 2 plus 1, 3, stores it into sum. It goes again, 3 is less than 0. It goes again, it adds 2 plus 1, you update your counter, 2 plus 1, which is 3. 3 is still less than, 3 is still less than whatever value you imputed in n. Me, I'm still saying 10, but let's see. The user can input 10, 0, whatever he wants to. But me, I'm still using the value 10. So it goes again. Let me just run it so it won't be confusing for you. Print the sum is sum. Let's run. So let me input my value. Then it prints 55. So what it does is the first check 1 is less than 10. 1 is less than 10. It goes into the loop, it adds 1 plus 1. That is sum plus 0 plus 1, sorry. Because sum starts at 0. 0 plus 1. It saves it into sum. It goes back, it updates the counter I plus 1, which is 1 plus 1, 2. It goes back, it is less than 10. 2 plus I mean 2 which is already stored, sum 1 which is already stored inside sum because you did 1 plus 1. It adds it 2 plus 1. It saves it into sum which is 3. It updates counter 2 plus 1, 3, goes back there, checks, and it does that until it adds 1 plus 2 plus 3 plus 4 plus 4, 5 till you get to 10 and it gives you 55. Let me give a simple while loop with an else statement. We say what counter is equals to 0. While counter is less than 3. Print number is inside the loop. Inside the loop. Inside the loop. Else. No, we still need to initialize our counter. Sorry. Keep having so many spelling issues. Counter is equals to plus or equals to 1. It goes into the loop and adds. Else print it is inside else. Let's run. So it goes, it adds 1, it checks 1 is inside the loop. 1 plus 1, 2. It checks 2 is inside, 2 is inside the 2 is less than 3. Count which is the counter, 2 is less than 3. It is inside the loop. It adds again 3. 3 is less than, it goes first of all, 0 is less than 3. It is inside the loop. It adds plus 1. 1 is inside the loop. It checks. 1 is less than 3. It is inside the loop. Prints out inside the loop. It checks again. He checks. He adds 1 to it. 1 plus 1 plus 2 plus 1 is 3. Is 3 less than 3? No. That means it is inside the else statement. That is what the else statement is used to print out. We now go into break and continue statements. Break and continue statements in Python often alter the flow of a normal loop. Loop iterates over a block of code until the test expression is false. But sometimes we wish to terminate the current iteration or even the whole loop without checking the test expression. Meaning there are sometimes we need to break out of an iteration, meaning before it checks that statement, before it gets the true value, before it gets the true or the false value, we might sometimes decide, okay, we want to break out of this loop. That is where the break and continue statements are used in this case. Let me show you some few examples. Let's say we want to loop through a string and print out each letter in that string until it gets to a particular letter, then break up that loop. Don't continue to print. Let's write a simple loop for that. We have for val in, let's call the string, let's just call it string. For val in string, then we write our if statement. If, sorry, I always keep forgetting my semicolon. If val is equals to I, meaning when it gets to I, break off. Don't forget a semicolon. Break. Print val. Now let me print this outside the loop. Just a front statement outside the loop. print the end. Now let's run this. As you can see, it printed str. What happened to n and g? That's because we used the break statement here to break off that loop before printing out any other thing. So we just wanted str. If I had done this without the break statement, this is what would have happened. Let's remove this break and if statement. Let's run. As you can see, it printed out string. Okay, let's check out the continue statement. The continue statement is used to skip the rest of the code inside a loop for the current iteration only. Loop does not terminate but continues on the next iteration. You enter the loop, test the expression of the loop. If false, exit loop. If not, continue. Yes, loop again. No, remaining body of the loop. Continue until you get false. Let me show you a quick example. Simple example, I'm still going to use the same code that we used before, but instead of using break, we'll use continue. When I run this, do you see that string is spelled out, but there's something missing? I is missing. That is because it went through the loop, it printed out S, printed out T, printed out R, then if val is equals to I, continue. That means jump over whatever you needed to print out before and continue the loop. So it jumped over I, didn't print it out, then went back, brought in N, brought in G. This now brings us to our class challenge. As I said at the beginning of the video, we'll be having a simple class challenge. It's very simple. Let me explain it. Prime numbers are whole numbers that have only two factors, 1 and the number itself. The first few prime numbers are 2, 3, 5, and 7. In the following coding environment, write code to check if the numbers provided in the list check prime. I'm going to give you a simple list. Check if the numbers in those lists are prime numbers. Then print out if the number are prime numbers, the code should print out number is a prime number, meaning this is a variable. This is a variable here. Whatever variable you want to call it is a prime number. If the number is not a prime number, it should print out number is not a prime number. Example of output: 7 is a prime number, 26 is not a prime number. This is the class, this is the variable check. This is the list check prime numbers. You're going to be checking in between 36, 39, 51, 53, 57, 79, and 85. Check in. Loop through this list, use an if statement to check if 26, 39, 51, 53, etc. are prime numbers or are not prime numbers. Before we end the class, we will talk about Python pass statement. The pass statement is a null statement. The difference between a comment and a pass statement in Python is that while the interpreter ignores a comment entirely, like the interpreter does not see a comment, pass is not ignored. The interpreter sees it, but nothing happens when it is executed. Let me give a simple example of a pass statement. You have a sequence. Let's give a simple list, or call it sequence, or let's call it equals to T. Funny enough, I'm spelling pass. This doesn't mean anything. I'm just joking around. So for simple loop, for val in sequence, pass. When I run this, you see that nothing. When I run this, you see that nothing happens. Nothing happens. And so that brings us to the end of today's class. I do hope everyone participates in this challenge to help you understand better on all I've taught today. In our next class, we'll be talking about functions, arguments, and several other things. I do hope you join us next time. Thank you for watching. I'll see you next class.